thanks everyone for coming to this panel discussion. I'm really excited about this. You've heard me talk a lot this week, and I mostly now just get to ask questions of smarter people than me and get their take on some of these concepts that we've been talking about. So just in case, I'm Jonathan Wise. I'm CESMII's Chief Technology Architect, and I will be the moderator for this panel. And I'll ask each of my panelists to introduce themselves and where they're from. And we have to share mics, sorry.
No worries. Hey, everybody. I'm Travis Cox. I'm the Chief Technology Evangelist for InductiveAutomation. We're a software vendor and partner with CESMII, and we provide the Ignition software platform and are very much on a proponent of making sure that we build things on open standards.
Excellent, I like that. So I'm Erich Barnstedt. I'm the Senior Director and Architect for Industrial Standards at Microsoft. We make software. And yeah, I've been working at Microsoft 22 years and mainly in the manufacturing industry, and I've been working with CESMII for about 10.
Hi, Steve Blackwell. I'm the Worldwide Tech Lead for Manufacturing at AWS, Amazon Web Services. I own the overall technical strategy for AWS in the manufacturing domain, which includes open standards.
I think this one works. Maybe it doesn't. Is it working?
It's on.
Oh, okay. Andrew Ellis, Rockwell Automation. So hopefully I won't go through an introduction as you heard me today earlier, but we are fully behind CESMII. I think I know we're not maybe so supposed to say standards, but I like saying standards, like consistent ways of identifying information and data to make it easier to integrate together is the way to go. So happy to be here.
Hello, I'm Srinivas Kuppa. I'm the Chief Strategy and Product Officer for Symphony AI's industrial group. Symphony AI offers industrial data operations platform and software solutions that are focused towards manufacturing, reliability, maintenance, in those areas.
All right, awesome. So this is a pretty incredible panel. I want to hit that topic that Andrew just brought up. So there's standards, as in published standards ratified by a standards body. And then there's an attempt to do things consistently kind of within the scope of a project. And maybe the phrase most commonly used for that sort of concept is the unified namespace. So that's a bit of a buzzword. It means different things to different people, and I would like each of you to tell me what it means to you.
All right, I guess I get to go first because I sat next to you. So yeah, no, UNS for us, it really represents an architecture change for how organizations are putting together their strategy. For so long, if you look at how we built SCADA or how we build MES or various systems, kind of that siloed approach in terms of I'm going to connect to the data that I need for that system, and I'm going to build that system. And you know, and all the things you're going to define are the domain knowledge within those teams and that system by itself, and not necessarily shared to other teams or to other parts of the organization. So when you look at a unified namespace, it's about being able to decouple the data from the applications to be able to provide that to in a centralized way that lets everybody get access and get meaningful, insights off that data in different ways. So it's really the idea of democratizing data, and it's a concept. There's no one product that makes this happen. It's got to be a strategy that the company comes up with, and leveraging different products and open standards and protocols to make that possible.
Yeah, so when we started off about 10 years ago building an industrial IoT platform, we also realized that the most important thing is to have that unified space, let's say, of all the metadata from all the different assets, all the different systems that you're connecting, because without that unified metadata store, let's say, you can't do any analytics. Only if the data is in a consistent format and you know what the data actually means can you do decent analytics on it, and that's what customers want to do with the data. They don't want to just collect data for the sake of it. They want to analyze the data and get some insights from it. So while I 100% agree with the UNS concept, it's actually been around for a long time. And to be controversial here, and we're on the panel, I just don't think it should sit in the broker. I think it should sit in the database where all the other data is, but that's just me.
So at AWS, we have a thing called the Industrial Data Fabric Framework, which is an architectural framework with a set of patterns for ingesting, storing, contextualizing, and enabling manufacturers to act on their data. And UNS really for us is a data architecture that sits in that ingest layer for manufacturers to organize and access their industrial data across OT and enterprise systems.
And I think if you're late to the panel, you have to get all the other questions right. Is that how it works?
I was going to take a chair away, and if you get an answer wrong, you have to stand up.
This is a tough crowd. There's work happening.
It's really, Doug, you just go ditto. That's all you got to say. Like, there's not much else to say. I'll say this. My point of view is probably UNS is a means to an end. I mean, at some point, we've got to organize our data. Customers are trying to build applications and solutions, be more productive, drive sustainability, fill in the blank, you know what those all are. And the only way we're going to get there, whether it's one machine, one line, one factory, all your enterprise, is to have a common way of documenting what I'm trying to connect to and describing it. And I think UNS is the best way that we have to do it. I'm all for, I'd rather be consistently wrong than randomly right, I'll say, because I can fix consistently wrong. It's like trying to pick a lottery ticket and lose every single time. Yeah, sure, some people might do that. But, if you're consistently wrong, you're doing something right. If you go to the horses and you consistently pick the loser, it's almost as good as picking the winner. So I think consistently wrong, I can fix that. So UNS to me is the way to go. It's a great way to describe your factories and your equipment.
So the way I would explain is in two different ways, right? So namespace is a very computer science API type of terminology. At the bottom of it, really trying to bring a common definition of an entity in the system. So traditionally, companies, manufacturers in particular, have been purchasing assets and running through their protocols, writing pieces of code on PLC in different ways. Over a period of time, they realize that it's very heterogeneous. And when they're really looking for their outcomes, when they're really trying to be more efficient, scale, some of the hurdles that are coming in is with the equipment and the processes that they have put in place. So they have to really bring a layer of commonality that really serves various functions at the OT and the IT level. I mean, it'll extend over to IT and enterprise over a period of time, but if we focus on OT, that's a must to really get that meta-model layer properly situated so that you can identify your assets, identify your process, do so real time, and take some key decisions. For that, a certain level of commonality need to be drawn in, and that for me is what a unified namespace is.
I'm going to borrow a few words from John from Anderson Windows that you said earlier, and you said what we're trying to build is a cyber-physical production system. And that really caught my attention because it's really a lot bigger than just a smart manufacturing or connecting machines. It's really trying to work out how to run a complicated multi-tier supply chain intelligently. The only way to do that, in my opinion, the most important thing is having it at UNS that we can agree on what it is and the semantics that hook things together. It's therefore a little unfortunate, and I'm going to go out on a limb with the political side, that the term UNS has become almost political. It's become associated with different vendors and different opinions. I think we need to get past that. Profiles are incredibly important for being able to define things. Probably the most important things we need to define are the things that we make and the things that we buy and the contracts that we enter into with our customers, the genealogy, the provenance of the things that we make, and this is what's going to drive digital passports, and it's going to drive sustainability, and it's going to drive supply chain resilience. All of which makes it a little naive to believe that the UNS can originate in the machines, which is the essence of the debate that's happening at the moment, which is you should just have it happen organically. A UNS is driven by your business model. It's driven by the promise you make to your customers and what you need your suppliers to be able to tell you. And those things become factual and truthful if the data comes from the machines. So the machines are vital to have as part of the UNS, but they're only the bottom of the layer, and the stuff that matters is at the top. and Andrew, I fundamentally agree with you. It's a voyage. It's a long-term thing before we can really get to the point that we agree on what the real elements of a UNS need to be. But let's start doing it, because it's not that hard.
Well, I heard some good things there that I don't think those with UNS religion would largely disagree with. I heard that it's a hub and spoke model, but I also heard that we need to be able to deal with data at rest. I heard that it's about semantic consistency, and I heard that it needs to be driven by business language, not just machine language. I think all of those things are worth considering, but maybe it's worth a call out that that's not really a unified definition of a unified namespace. And it is that unification that's the part that bothers me most about UNS as a concept. The word namespace I'm very comfortable with, and when we were toying around what we would call information models or information templates, I threw out namespace, and we all decided that was way too geeky. The average person doesn't know what a namespace is. We'll call them profiles instead. So I'm a little jealous that some group somewhere managed to explain a little bit to a broad audience what a namespace is. That was worthwhile. I think understanding that our symbols may have different meaning depending on the namespace they're in is an important part of computer science. I think there are, I shouldn't lecture, I'm the moderator. I think there are use cases where a hub and spoke model or report by exception work. I 100% agree that our unified namespace, if that's our interface, has to have access to historical data, and that our unified namespaces, the namespace part, needs to be informed in collaboration with the business, but also with our business partners. So I'm going to direct this question at Erich. Shut up. Erich, how do we move towards a more globally unified namespace?
So as I mentioned before, you know, in my opinion, the metadata and the data should be in the same place. That allows for a performant querying of the data, because you always need to query both. And to be honest, you know, the OPC Foundation has developed a mechanism to describe assets on a global scale many years ago. It was like 15 years ago. And the combination of the OPCOA application URI, and the U in URI stands for universal, right? Coupled with the combination within the machine, which is a namespace and a node ID, because everything in OPCOA is a node. You put those three things together, it's in the spec, you can read it, and you have a unified namespace. And I happen to call that out on LinkedIn, and I got shot down by the usual suspects, let's say, but I still think it's a pretty good solution to the problem.
I'm going to redirect a little. Thank you for taking the OPC perspective, which I think is valid. It is awesome to connect to an OPC UA server and see the address space that includes the namespace definitions, the type definitions, and the instance objects of those types. That's like the dream. In actuality, most UA servers that I connect to don't really have types in their address space at all, or it's base object type.
Yeah, and I mean, to be honest, a lot of people obviously didn't read the spec when they built their OPCOA server, and I saw all sorts of crazy things in the application URI, including IP addresses. So you got to read the spec, and you need to actually follow it, otherwise it doesn't work.
All right, so if you read UA and follow the spec, you can get to this ideal world, but our architectures are heterogeneous. We're going to have UA data sources. We're going to have Modbus data sources, and you showed this morning how we might adapt Modbus to this better world, but we're going to have MQTT data sources. We have Sparkplug-B, where I can get an nbirth that is effectively a type definition. So I would argue that, I'm lecturing again, that we need an external reference for these namespaces, which is why we chose to position profiles outside of a server and keep them in their portable fashion. I want to invite others. How do you think we can solve a global unification of namespaces? What do you think are the steps we should be taking as an industry?
So to your point, most of the customers we speak to are brownfield. They don't have the luxury of building a brand new plant. So they're having to deal with all these disparate data sources. And I would say, I'm making a number up, but 80% of the customers we talk to, they don't even know what the data is on that machine. The manufacturing engineer that actually built, that machine is long gone type thing. So if in the whole process of connecting up those machines, those systems, it's really kind of discovering and understanding what data they actually want off it. So we really see, namespaces or UNS or whatever you call it as kind of two parts. It's one, a lot of our customers are seeing it as first, just the ability to ingest data, okay? And you can argue, is that Kafka or is that MQTT or whatever it may be. And that's really from a bottoms-up point of view. I just want to be able to get access to my data and be able to use my data for whatever use case it is. The customers that really are kind of looking at it from a manufacturing enterprise point of view also going, actually, we don't have a global information model here. We need to be able to standardize, especially if you've got, I always use the silly example, we've got manufacturers that have plants in Spain and plants in the US. Is temperature centigrade or is temperature Fahrenheit? As the most stupid schoolboy kind of example type thing. So they need to have a way to be able to have flexibility and scalability as they start to go to their smart factories or implement their digital transformation. But really also then be able to define a profile, a template, a standard information model that they can really build at that top level and kind of cascade down and build out as they go along.
I want to take the business angle to this, right? I mean, when you say global centralization or normalization of the data model, the question is why, right? Because we know for sure there's no way you can go in and create a global namespace. And there's no, in some ways it's counterproductive, right? Because some plants tend to run unique. I remember working a long time ago for Siemens. We used to have a customer in Singapore. I'm a medical device manufacturer. There they were forcing on having a unique process because they have to serve their customers, the country's regulatory needs. So at what level you want to unify it and for what outcomes is very, very important. It cannot be a technical endeavor of trying to say, I'll map every one of my assets, which are a few 100,000 by the next year and have them all tagged down. Is certainly not a very, it's a very technical approach to take. I mean, now answering the question though, instead of trying to be a counter point on it, the idea of global namespace, I think if we can get to a business unit or a set of plants that are working in coherence, especially in semiconductor manufacturing, for example, one plant cannot manufacture everything. Same is true with oil and gas, where the downstream processing happens. If we can take a group of plants that work in cohesion, transfer semi-finished material across them, and start creating a sense of unified namespace at that level, that in itself will generate a whole bunch of quality performance benefits than it would do trying to boil the ocean.
It came to me, I can answer too.
Yeah.
I think, to your point, I think it's about scope, because I agree, it's like, you can't have one massive namespace and the only namespace. Yeah. That's just not possible. So the scope, it's like, so from Rockwell's point of view, if I think of the hardware we produce, we could create namespaces for a drive, for a motion, for a sensor, for our controllers. We could create a really good namespace that then others could use to build their further namespaces, and the scope just changes. But maybe the master of that namespace is in that controller, but then can move up to wherever you want. So if you want to build a universal enterprise namespace that's got everything, you can, but it's federated to some degree, as opposed to the master lives at the enterprise. I think that's challenging to do, because how do you trust that data if it's not the source of the data?
Can I redirect the question a little? Sure. So I heard a truly global namespace is probably impossible. I agree. We don't even have a truly, hello? Oh, thank you. Everybody say goodbye to Dominic.
Everyone say bye-bye, Dominic.
Travel safe. We don't even have a truly universal version of English. So maybe being business case driven, defining consistent global namespaces in places where I need to interoperate with a business partner or supplier. That might be a good way to not boil the ocean. But I alluded to, and Travis is going to show in the next session, the ability to import a profile as a UDT. So there's some value to having repeatability even at the device or object level. What do you think that value is? Yeah, I'm giving the mic to you.
All right.
Why do you have UDTs?
Yeah, I mean, the reason to have UDTs or to leverage object-oriented design is so that you can guarantee that repeatability. So that I can define something once, define the characteristics around that, the configuration around that, instantiate it, and I know that those instantiations are going to follow those rules. And that when I build an application around that object, that my application can now be dynamic, can expand, can scale, can move from one location to another. I can leverage, other things that might have been built against that same model. So when you have that, you have repeatability, plus you have access to a wider community of things that might be available against that resource. So I mean, you have it because it's going to speed up development. It slows down. It's hard at the beginning because you have to define everything at front. You got to really put the work into making it right. But once you do that work, oh my God, does the next project become really simple? So it's one of those things that you have to see the long game, and a lot of companies don't look at that, right? These budgets are so short. These project timelines are short. They get impacted by supply chain issues. And all of a sudden now we have to cram all this in, and we're not going to build those beautiful models, or we're not even going to think about doing that because we're trying to get this done.
Just trying to get it done. Go ahead.
So I was just going to add, it also decouples the IT from the OT, and it significantly accelerates your industrial IoT projects, right? Because in older days, there's a shared contract, right? Which is the model. In older days, you would have to first connect to each machine, figure out what the data is, create some models around it, and then bring those models into the IT and model your IT. If you define the model up front, you can get your IT done at the same time while you're onboarding your assets and onboarding your sites, significantly reducing the time it takes to build these systems.
Give me a sec. So software development agility, I 100% agree with. I also agree with the resistance. So we funded about 60 projects during CESMII 1.0, and we learned really quickly if we didn't force the project teams to stop and model first, they wouldn't do it. And they would pay the price later. The first time, it's harder. It takes longer to model it right. But yeah, it's a new muscle. If you have the model, the second time is faster, and the third time is faster, and it just keeps accelerating from there. Go ahead, Doug.
That's part of the point that I want to make. It's from most of us in some way, shape, or form represent product companies. We would not for a moment dream of building our products without using well thought through object orientation. Never. Yes. So it's kind of odd that we're having a conversation about should our customers not do the same. So there's a weird sort of contradiction there. I wanted to make one additional point around the greenfield versus brownfield. There's actually really, really cool solutions at the moment to put wedges between your brownfield devices and the thing that's consuming the data to impose structure on their data. And those have been around for 30 years, and they're getting better and better. I think it's an exaggerated problem. We hear it so often, but I have a brownfield system. How am I ever going to have that as part of my system? Put a shim in between. It's going to get a lot easier with the Web of Things standards that are emerging and the likes of what we're doing. But they're pretty damn good solutions right now that allow us to put a shim in between and force structure on these brownfield devices, and the problem goes
I didn't
away.
give Eric time to show it, but he has a demo where he gives ChatGPT the manual for a Modbus device, and it generates the watt shim. Mm-hmm. Just takes care of it.
And I think AI becomes incredibly important here. If you look at the technologies that are doing the shimming, they look for patterns in naming. They do all sorts of clever things which AIs are just way better than humans at doing that stuff. Just look at this mess of tag names. And it takes a lot less time. Yeah. 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 So.
So if I can just make one comment about something you were mentioning earlier, and not here to, we're not here to debate MQTT or any of that, but I think we have to ground.
If you're an MQTT zealot, go to that side.
Yeah.
If you only do OPC UA, you go to that side.
And I think what I want to do here is just ground ourselves for a moment into the reality of where most organizations are, right? And the reality is that a lot of them still have clipboards and whiteboards. They still have morning meetings where they're going through trying to figure out what they did in the previous shift, the previous day, or previous week. And there's tons of data that is not even given to the right people. So I want to ground ourselves with that first, right? We have this world where people there's amazing new sensors and things you can buy, right? All the greenfield stuff is amazing. Plug and play. It's leveraging technologies like MQTT or OPC UA out of the gates. But we have a lot of brownfield. I think what MQTT is able to at least do for now is allow these two worlds to collide into one. And where people are thinking of unified namespace is a step above what we used to have, right? Where things were in applications, and applications were the API interfaces to, if they were there, to business. Now we have a way to actually leveraging standards to get data to the business in a consistent way. Now, should that be, leveraging the SM profiles? Yes, right? Can we get to a standard where everything's speaking the same language? That's going to come down to vendor support and interoperability that's going to be there. You have to get everybody to support the same thing. Otherwise, we're not going to get there. And I'm not necessarily saying that MQTT is the UNS approach. It's a way to unify the plant floor in a way that we haven't been able to do before.
One real quick comment. Yeah. I'm really disappointed because I thought you were going to say something really controversial. I was looking forward to a debate, but I fully agree with what you said.
I think MQTT has some other cool advantages, especially when you're starting to learn about these concepts. So if I have a nice JSON serialized payload in an MQTT broker, I have an untyped object. Like, that's a great way to learn about object orientation. If I have a schema, like what HiveMQ can provide to enforce the structure of that object, I have a type definition. So now I've begun to learn about profiles. So I think it is a useful tool, and I think in some places it's the right tool. But what I think it's important, and what I think we have consensus on, is that while we're probably not going to unify a global namespace, there are use cases, business-driven use cases, where it's going to be advantageous to have global harmonization. And there are software development practices that are accelerated with object orientation. And if we end up by an OPC path or an MQTT path with an understanding at the OT layer of what we all understand at the IT layer, that object orientation is like a table stakes for modern software development, then those objects begin to lend themselves to what I've been calling the knowledge graph. And so I now want this panel to tell me what a knowledge graph is. And I had an order I wanted to start in for my own reasons. I'm going to give it to Srinivas first.
Yeah, I'll go with it. So let's talk about unified namespace for just a second. I'll jump to knowledge graph because there is a connection to it, right? You heard two things very clearly. One, it's a very technology-driven conversation. Type def, namespace, you heard all these terms, right? And they have barely got started. The second thing you gathered is also that it's a journey. Unified namespace cannot happen overnight, 6 months, 1 year. It's a journey. You'll continue to add things because it's an evolving space in manufacturing. And now we have seen a lot of the times when it's a technology-driven endeavor, it takes a long time, no business outcome, it will fall apart eventually, right? So the knowledge graph is really meant to look at it from a top-down perspective, from an end-user value-driven perspective, to say all the great work that folks are doing, the data scientists, engineers, you name it, trying to really clean up the mess underneath, what kind of a value does it give you? So that representation of that is a knowledge graph, which takes a top-down approach. Of course, it sits on underpinnings of the unified namespace or whatever you call it. But then it focuses on actionable, outcome-driven, responsive data model or a meta model. I hate to say data model because it gives that static feel to it. But anyway, that representation that can be responsive, real time, and can be giving you outcomes to the end users and showing value. The second thing it need to do is really help find patterns that the end users may not otherwise have seen. Data patterns. Oh, you're getting delayed in your packaging side of it. Because you're getting delayed in packaging side of it, your orders are backing up. Oh, by the way, the energy consumption is going up as you now need to run a new shift. These kind of things cannot be predefined query-based. These data patterns need to be identified by the system, smart enough, using AI. Generative AI really helps that in that space. And then start showing the patterns to the end users, the production managers, and others to take action. Now, that again is a long journey. It cannot be a flip of switch. But once the bottom-up approach is taken from the unified namespace, a top-down from the knowledge graph, you really have a business value being generated as we do these technology-driven endeavors. And of course, they're interconnected. I'm not saying somehow a magical top-down knowledge graph would show up when in fact the underlying layers are broken up.
Thanks. Doug gets it next. Then Steve. Then you can go.
I'd like to draw a distinction between what the knowledge graph's real strength is versus profiles, which are the types that help you build a unified namespace. I think there's a general guiding principle that I hope people will start seeing as profiles become more common. If you're writing your own profile from scratch, you're probably being inefficient. If someone is telling you what the knowledge base of your company looks like, you better be paying them a lot of money. Your knowledge base is yours. It defines the relationship between your machines and your people and your products and your intellectual property and your methods of operation and how energy affects quality and everything of that sort. And as we model, as you build your unified namespace, that's where you should invest, is building your knowledge graph. Not trying to decide what a CNC machine looks like. Because no matter how special you think your piece of metal is, it's just a CNC machine. Sorry, they're awesome machines. So there's some beautiful ones in the building. My apologies to the CNC machine builders. But the principle, I think, is really important. So that knowledge graph.
Your knowledge is what you do with that thing.
Yes. Yeah. And that's where you're going to be able to get the business value. Because a well-structured knowledge graph that really reflects what you're dealing can now answer the business questions as to where are my bottlenecks? What's the underlying cause? What's causing the starvation? What are the things that are introducing my quality problems? How can I make more? Will all come out of the knowledge base. And it's yours at that point. So they're very orthogonal conversations. And the one is really worth spending your time as an organization building a good one for yourself.
Okay. So maybe I'll be a little bit controversial here. We'll see. We'll see if Erich attacks me or not. So
Never.
that's true. Once I get outside.
I know where you live.
So from an AWS point of view, UNS, we really call that data enrichment. Okay. When we talk about knowledge graphs, we're really talking about a graph database that resides within the cloud. And the reason why we make that distinction is when we talk to our customers about what the problems they're trying to solve, and I'll go back to kind of your examples, it's bringing multiple different data together. You know, I always like to use the example of like quality. You know, I've got a welding robot, you know, welding body parts together for a vehicle. I've got a quality defect being raised. That's obviously that quality defect is resided in the MES system or the quality management system. But then you've got all the telemetry, the industrial IoT data, the time series data that's come from that robot that tells you what the median fit speed is or what the current was when that weld actually happened. A lot of cases, you know, that's coming through two different systems. It may have been ingested by UNS, but the way it's been stored is in a relational database and in a time series database. And really where kind of knowledge graphs or graph databases come in is it allows customers to build a specific data model that brings the relationship together between all those different data entities. So whatever use case you're looking at, I'm a quality engineer. I want to see all the defects created for this particular product. Or I've got 3 or 4 suppliers for a particular part. Show me all the suppliers that actually provide this particular SKU number, so forth. You're doing queries across multiple different data sets. And the only way you can really actually do that efficiently at scale is having that kind of knowledge graph kind of built across that. So.
Yeah, I want to open this up to everyone else. Just let me just call out something really important there. Doug identified that your knowledge about your process is a key part of the knowledge graph. And Steve identified another layer of a knowledge graph that brings in other information sources. And I think both things are true. A graph is not one layer of the onion, it's multiple layers of the onion. I want to open this up to anyone else. Definition of knowledge graph, how do you use it, what's it for?
So I'm going to just say I am not an expert on knowledge graphs. I learned them last week. So no, but I think it's, when I think of those it's the capabilities you can have with a UNS. It's like, sure, I could probably make a UNS look like a knowledge graph, but it would be so much harder. And therefore, having all those infinite relationships, edges, whatever you might have called them, to me makes looking at a standard database with tables and columns and querying that pretty simple. But now, if I had relationships that I knew nothing about, that query becomes extremely complicated. Knowledge graphs appear to solve that problem.
So I'll give a simple example, right? We used to work with a company, it's a glass manufacturing company. They have 50+ furnaces. And what happens is once in a while when the material is of lower quality or whatever the reason is, or the furnace is already heated up, you got to, or it's getting cold, rebooted, you have to bring in these boosters and then the energy boosters to get the furnace going. And that consumes high amount of energy up front. And if you look at the energy profile, yeah, I mean, that's probably taking a whole lot of energy and converting it in dollars. That's a loss. So now why I'm taking this example is that particular company may have the perfect unified namespace, but this anomaly that's happening around trying to put a booster where the energy is getting consumed, for which the operator knows when to bring in the booster, when to shut it off, try to be optimal in his own way, that knowledge will not be captured in unified namespace. That's where the knowledge graph comes in. And how do you represent it in a technology sense? Of course, it can be debated until cows come home, but that's the difference of it. The what's that human element is doing there and capture that and then do it at scale. That is where the knowledge graph differentiates itself from the so-called unified namespace or unified data model.
Yes, I agree with everything that was said, including what Steve said. But in, seriously, this concept of knowledge graph is so important for machine learning, for AI. There is no AI without a knowledge graph, and it is the single source of truth that everything else hangs off of. And at Microsoft, we've actually, realized that, in recent years, and have combined our time series database with our graph database, because the two, the time series database obviously is for your sensor data, and the graph database you build up either through importing from different data sources or you build it up yourself, whatever you prefer. But it is the source of truth that everything else runs from, including training your machine learning models. So it's a critical component that everybody should get familiar with.
Awesome. We're running low on time, so I need to move to the next question, but I think that was a really good discussion. I'm going to aim this one at Travis and then Andrew first, and then, again, anybody else is free to answer. What's the importance of interoperability? And since we're almost all vendors here, how and why does your organization keep interoperability in focus?
Well, I could say for us, interoperability has been a kind of core part of our DNA from the beginning. We started just as a way of being able to just get data into IT technologies, right? Getting into a SQL database, making it available to more people. And when you look today, for so long, if you will, what people are trying to do in their digital transformation journey wasn't brought to light until we started putting these terms of digital transformation and UNS and all these things, where now the business side is starting to think about the data and what it can mean to them, right? And so interoperability is crucial because no one product is going to fit the bill to do all of it. There's no one size fits all solution. It's going to require lots of products. It's going to require the company to develop their own strategy. You got to develop your own strategy. You've got to know what you're trying to do, and then you're going to fit the ecosystem into your strategy. And the only way that's going to work is to have standards and interoperability of the products. So if you want to stay relevant as a vendor, whether it's software or hardware, you've got to adopt that mentality.
Yeah, I think Travis, totally agree. And you said something earlier that I thought I'm going to jump on is most manufacturers that we work with, customers we work with, if you look at the digital maturity on any scale, we use a 1 to 5 scale from Bioform. There's lots of scales. The reality is the average is just above 2, meaning barely got a PLC controller. So flying cars, we're a long way from that. So the way, but yet these same customers want AI. They want robots. They want advanced technologies. But the only way they can get there is if you have solutions that can connect to all those different systems to surface that information to give to these AI, robotics, whatever it may be, IoT. So I think interoperability is key. There's no doubt, if I look at back our history, we came from a place where we had proprietary RS-232 drivers, and that's the way the industry was. I think we have completely changed to open standards are the way to go. We have to connect to everything. Gone are the days our SQL is the unifying, protocol. It's now OPC UA, it's MQTT, and list all the others. So I think it's just the way we have to go, such that we can connect to all those things in those brownfield sites, because there's no way, the number of greenfield sites are just not big enough. You have to connect to everything. So I agree there. Comments?
Very quick comment my side. So when we set up the industrial IoT team 10 years ago, we asked customers, so what was their biggest adoption blocker of Industry 4.0 solutions? And without a doubt, it was vendor lock-in. So interoperability removes vendor lock-in. So we set up our entire our strategy and architecture around openness and interoperability. And since then, my telephone hasn't stopped ringing. So it really worked, and it helped us, establish, us in the market. So it seems to be important. Yes.
Like I say, one more thing about that is, if I were put into an organization's shoes, let's just say I was an end user and I was part of the strategy, I got to figure out what we're going to do. I think it would be really difficult to kind of get through the noise that's out there, to understand what am I putting in and how does that connect. The transparency is not necessarily all the way there. And if it does support a particular standard, like OPC UA is a perfect example. We've supported it for a very long time, but we don't support every profile, every companion spec that's there. We're adding more as the need is there. But you have to be very clear about what part of that specification that you are supporting, what parts you're not supporting, because that plays a huge role in interoperability.
I would say OPC UA is not a checkbox.
It's not a checkbox, and there's even ambiguity within the spec in terms of a client and a server, and having them actually work in certain areas. So this is what, again, comes down to more emphasis on the standards, more emphasis on interoperability and having interops. I remember the old days of having OPC interops, where we'd sit around a room and that we would just test implementations to make sure they work.
They still do them.
I know they still do them, but we need to do that at a broader scale, right? That needs to come back so that everybody is playing towards the same common goals, so that we can achieve interoperability.
At the end of the day, it's market dynamics, right? If you had gone 20, 25 years ago when one operating system came up, for the second one to show up by another vendor, it took forever. By then, that particular vendor locked a bunch of end users by then. Now, ChatGPT came in. Now you see ChatGPT came out within a week or two. You saw Llama coming out, some other things coming out. Now we have a flood of large language and small language models coming out. So, the vendors, the alternatives are out there. So it's in the good interest of the manufacturers to force for it, and vendors to go do it, because that really is, that makes economic sense.
I'll hand it to you, Doug. I think from a manufacturer vendor of these systems, we would love to have one standard. It'd be fantastic if someone said, OPC UA is it, done. We could spend our money on other things, adding other features and other capabilities, but the challenge is there's a ton of standards that people expect us to work with, EtherCAT, MQTT, the list goes on. And so we got to be selective. So I'd love for industry to say, that's the one we're going with. It would just make life so much easier. I'm not whining, not whining.
Your first question, yeah. Your question really went to why is interoperability important, was where you start. The Gartner survey slide that we saw in the session just before this one really nailed it. 86% of the respondents said their biggest problem, their biggest challenge was trying to integrate different products. It's really, really hard. I don't think in the last 10 years you could have bought a credible piece of software that didn't claim that it was already interoperable. So interoperability is something that we've all been talking about for a long time. And I think the reality is people play lip service to it. CESMII is just beginning this voyage with the RFC that you've put out. It's tough to get to real interoperability. It's really, really hard. And protocols are a tiny piece of interoperability. It really comes down to, do you have interrogatable models? Do you have modern software? Do you have good APIs? Do they have the right level of richness? A huge number of things go into creating real interoperability. And in manufacturing, it's particularly difficult. Somebody apologized earlier today for using the childish example of engineering unit conversion. No apology was necessary. The number of things that just render our software useless because it doesn't tell you what the engineering unit is, because that's optional.
Well, and how many entries were in that Unicy engineering units table? Like 1,400 engineering units?
1,400 from the European standard. And then NASA has their equivalent, which has about 1,400, and there's only about 60% overlap.
Yeah, NASA's been known to get it wrong, too.
So in the industrial space, interoperability is particularly difficult because it's cyber-physical, it's real world, the consequences of getting it wrong are high, and we need to take interoperability really serious.
Yeah, and I appreciate you calling out. We often talk about it at like the machine data access level because that part is a pain in the butt in our space. But if we don't take interoperability seriously, and we end up with proprietary software that manages their own connections, and then each tries to own their data or their enriching of their data in their little space without being interoperable, all we've done is move the problem up a layer. The software needs to be interoperable as well, and we need to do better than we did with machine connectivity. All right, we have a couple minutes, and I wasn't supposed to do this, but we rarely get this much brain power all together. So I will take a couple minutes of audience questions if there are any. Jan's already locked and loaded.
Yeah, I'm locked and loaded. Let me add a little bit. Jan from Lockheed Martin. I like your opinion on ontologies. Are UNSs linked to? I like to be controversial here. Shouldn't the UNSs? So the question is, should UNSs not be linked to high-level ontologies?
Yes. Next question. Sorry, couldn't resist.
You want to answer in more depth?
Oh dear, yeah, that was the correct answer. Of course, right? And of course, ontologies add that language that you need as well. I mean, it provides the semantics. So I would say you need four things. You need interface, data model, data format, and semantics. And only then do you have interoperability. So your ontology is the semantics. You need all four.
Yeah.
And engineering units.
The ambiguity part of it goes away if you have the ontology. I mean, the synonyms, the antonyms, you know, the alias naming, or any recipe, regular expression that you want to tie to certain smart numbering schemes or other attributes. These are fundamental. I mean, even for doing an enterprise search, it need not be just for unified namespace. For you, if you want to really create the building block of creating an enterprise search or some kind of OT broad-based search capabilities, starting with that kind of basic ontology or taxonomy, that's fundamental.
Hi, my name is Aldo Ferrante with Sorba.ai. One of the questions I don't think came up a lot, doesn't open standards promote more security issues? And then how do you secure that? I mean, we have NFGs for images. Are there concepts to secure that data? Because as you expose that, that becomes a problem.
At least from my perspective, when we talk about, you know, open data, accessible data, that's really more of a concept. You know, we also say, you know, security is job zero. So that data is open, accessible, but it needs to be encrypted, at rest, in transit. You know, it's only open and accessible to the relevant people that are allowed to actually have access to it. So when we talk about, you know, a data architecture or an information model, you know, adjacent to that or sitting on top of it, depending on how you want to picture it, is you've got your identity and access management, your RBAC system saying that, I'll go back to my example of quality, you know, these quality engineers for this particular product are only allowed access to this particular set of data, you know, so that it's open, accessible, and they can use the data as they see fit, but are allowed to use the data.
So two things. So I would argue that in an open standard, there's far less security bugs than in something proprietary that people have come up with. That's number one. And number two is there's, you should differentiate between the control plane and the data plane. What we've been really talking about here is the data plane. There's a whole nother plane of access, thank you, which does authentication and authorization, right? And there's different tools available for that. And yes, it also has to be secure. So the data plane is secured by encryption. The control plane is secured by access control and certificates and authentication and IDs and all those things.
One more quick one.
Okay, this is Prakashan from CESMII. I hear you guys fighting over OPCUA, MQTT, and all. So if I
We weren't fighting.
okay, I mean it's some. Okay. Okay. So if I connect an Arduino and a sensor to my laptop right here, the data coming out, I can send it by MQTT or OPCUA, whatever I like. Why can't the manufacturers do the same thing and give the people option?
Yeah, right. Yeah, do you have an answer to that? We all agree, yes. That should happen.
Okay.
So just because it comes up as only in the US, it never comes up in Europe for some reason, but there is no OPCUA or MQTT. OPCUA is protocol independent. It has a binding for MQTT. You can send an OPCUA payload over MQTT, and a lot of people do that. So there is really no discussion should you use one or the other. The answer is always yes. Use both.
I just want to say I agree. It's never been a versus between these protocols, right? They're complementary.
But some people make it that way.
A lot of people make it that way, but it is very complementary. They were designed for specific use cases. Let's go back, right? OPC has its place in control, in plant floor, and level 1, level 2. That's where it started. And there's, I mean, it's trying with UA to go higher levels, right? And that's where the data profiling, all that comes into play. But you need adoption for that to happen. And let's face it, the spec is harder for some companies to implement. It's a big spec, right? So, you know, I would love for products to have all the standards supported, because at that you get the option to choose what makes the most sense for your use case, for what you're trying to accomplish, right? Because if it's something I'm just trying to get data up to an application, to store it, and just visualize it, there's no control. You know, why not use a very simple, lightweight one? But if you're trying to do some real control, and then there's purpose-built ones for that. So, I mean, anyways, it's a difficult challenge.
MQTT is so simple to use, especially you are coming from a private subnet and broadcast all the way to the public subnet. MQTT is very simple, whereas OPCUA to do port forwarding and a lot of difficulties there.
Well, if you did pub sub, you wouldn't have to, but we could talk about that later because we are out of time. I want to give everyone just a lightning round here. What call to action do you have for CESMII members? What should they go from here and do? And I'm going to start with Travis next.
Yeah, well, I think the most important thing is an organization has to kind of step back and take a look think about their data differently and take a look at their organization and put an emphasis on let's define what this means to us, whether that's use existing profiles or contribute to new SM profiles. But that should be journey one. Once you've defined that, then you start deciding what your strategy and products you're going to bring in to accomplish it. So I think it's really important to do that.
I would say my call to action is, please, for the love of God, start using profiles.
So first one is you need to have a data strategy in place. That's job one. Job two is you need to, whatever you want to call it, profiles, information model, but do not spend the next 2 years going into a back room and developing it. You know, start from, 1, 2 use cases and use those use cases which the plants, the manufacturing sites see value from to drive building out that information model.
Steve got 2, so I get 2 as well. I would say from a CESMII point of view, being biased there, is go back and say, wow, like we've got competitors up here who when we leave here, we're going to go fight for sales. But up here, we're consistent. We want this. Like what CESMII is driving is consistency and adoption of smart manufacturing. We're all for that. So go back to your wherever it is and kind of share that message. To me, I think that's important. And then increase the education of what you're doing here. And I'm going to agree with Erich, is start using standard profiles, because I think it just is the way to go.
See, a lot of manufacturers are already on this path, right? Trying to take the data together, do something with it, contextualize it, name it whatever. So as long as your data contextualization endeavor is in the direction of matching with your core competency of you as a company, with your business goals, your business processes. If your data contextualization is perfect, but not really matching to what you do as business, it's a mismatch. So as long as your journey of data contextualization and capturing that knowledge is in line with your core competency as a business, if you have those measures along the way and validate it, yeah, that's what I would suggest, having those guardrails along the way.
I think everybody should go out and evangelize, because something extraordinary is happening. We have organizations that couldn't talk to each other just a few years ago, having deep conversations and conceding ground and changing their minds about how they're going to do things and agreeing around things that have held our industry back for 30 years. This matters. And go talk about it. And start using profiles.